Hello everyone, this is Divya, Assistant Professor, Department of Computer Science with Data Analytics, Dr. SNS Rajalakshmi College of Arts and Science. So in today's Big Data Technology class, we just go through on Advanced SQL. So where the Advanced SQL in Big Data Technology, which is mastering the modern SQL techniques, which is processing for the huge amount of data set at the scale here. So when we just start with the introduction to SQL evolution in big data technology, where the SQL has evolved dramatically, which is from its origins in a relational database to become the big data processing, which is the modern SQL engines now handled, which is distributed data, maintaining the familiar declarative syntax, and also data professionals which are having the evolution enables organization to making the existing SQL expertises, which is scaling to unpredictable data volumes, and also the processing speeds of across the computing cluster, which is making the more easier. This technology has been enhanced. Traditional SQL versus big data SQL engines. Normally your traditional SQL, which is having the single node architecture, and also which is now row based storage or concept has been implemented in our traditional SQL, and vertical scaling concept has been used in big data SQL, which is distributed processing, eventual consistency, and also column formats also making the thing very easier. Now horizontal scaling here we have implemented here. So normally your traditional versus big data SQL, which is having the two different poles, single node architecture, which is a distributed, when we other hand, which is a distributed processing here. So row based storage, obviously here we just using the column format for the big data SQL here, so which is making the technologies or processing very which is easier or which is advanced here. So Apache Spark, where the Apache Spark SQL architecture, which is having the performance, that is which have three categories here. The advanced query optimization of the engine that transforms the SQL queries into the efficient execution plans through the rule based and cost based optimization strategy here. When we optimization CPU and memory efficiency through the whole stage and code generation, which is enabling the near native performance for the SQL operation across the massive data sets, which is data frame API, that is providing you the unified abstraction for the structured data processing, which is allowing the seamless integration between the SQL queries and a programmatic transformation here. So advanced query optimization techniques, where the predicted that is predicted push down, that is filter data at the resource layer, which is before loading into the memory, and dramatically which is reducing the input and processing overhead for the selective queries. When we column pruning, that is read only requires column from the storage and leveraging the columnar formats like which minimize the data transfer and memory consumption here. Where the partitioning, where the skip entire data partitions that don't match query predicates, and enabling orders for the faster query execution on the partition data set. These techniques work to transform the query performance, and particularly when the processing structured data in formats designed for analytical workloads here. So window function analytical queries at the scale, where the power of the window functions, where the window function enables the which is analytical computations across the ordered partitions of the data without any requiring the expensive joins or subqueries here. That is which is running the total and moving the averages, and the rank calculation or lag comparison and complex time series analysis, everything can be done easily here. So a small example program I have just written here, that is select user ID when we making the attributes of user ID and transaction date, amount, and some of the amount over the partition by the user ID, which is ordered by the transaction data, where the row between the unbounded proceeding and current row. So where the average of amount and partitioning, which is by the user ID, and order by the transaction, which is having we collected over here. So distributed join strategy and performance tuning, where the broadcast join and shuffle hash join and short merge join and bucketed join. So optimal for the small tables with maybe a less than 10 MB. The smaller tables of the broadcast to the all the nodes, which can be eliminating the expensive shuffles and conflict with the Spark SQL and auto broadcast join threshold here. Short merge join, that is difficult for the large tables. Both datasets are shorted and partitioned by the join keys, which is allowing the efficient merging and without loading any entire dataset into the memory here. So shuffle the hash join, which is used for the medium data set, which is in either table fits in memory or data is redistributed across the partition based on the join keys, which is enabling the parallel hash joins here. So bucket join, which is pre-partitioned tables, which is enable the join operation without any shuffling here, which is require the upfront organization, but which is delivers exceptional performance for the repeated joins here. So SQL on no SQL, that is querying the semi-structured data, where breaking the traditional boundaries, that is modern SQL engines, which is Excel, which is a querying sigma and read data formats, which is including the JSON and XML and a nested structure here. This flexibility enables analytical workloads and across the diverse data sources without any enforcement, right? The schema discovery, that is automatically infer the structure from the semi-structured data. Nested navigation, that is query deeply nested objects using dot notation. Array operation, which is explode and aggregated complex array structures. Real-time SQL processing with the streaming the data, the stream integration and stateful processing, which is continues the data arrival from the particular event hub with the any microsecond latency and exactly one semantic here. When the stateful processing, which is maintain the distributed state for the complex event processing and also incremental computation across the streaming data here. Windowed aggregation and output modes, where the tumbling and sliding and session windows enable the temporal analytics or unbounded stream using the familiar SQL syntax, where the appended complete or update the modes, which is determine how the results flow to downstream sinks and dashboard in real time. Best practice for the SQL performance in big data environments, with the partition strategically, which is organized data by the commonly filtered columns, that is date, region and category, which is avoid over the partitioning, which is create the small files and metadata overhead, and aim for the different partition size here. The choose optimal formats, which is having the ORC provide column storage with efficient compression, use the appropriate encoding schemes, and enable the dictionary encoding for the string columns to the maximize compression rations. Cache intentionally, where the cache frequently accessed intermediate results and dimension tables. Monitor cache utilization and eviction patterns. Consider using the delta lag or Icebridge for the automatic caching strategies. Where I am taking the case studies and implementation example, where the e-commerce analytics and financial service and telecommunication. Over the global for the e-commerce analytics, which is the daily clickstream data using the Spark SQL with the delta lag, the query latency, which is reduced from the hash to the minute through the Z ordering and data skipping here. Where the financial service, which is investment banks, runs real-time risk calculation on the streaming market data, which is the window function compute rolling the across 1 billion trades per the day with the secondary latency. Where the telecommunication, where the network provided analysis of call detail records monthly, which is broadcast joins and partition pruning enable the complex customer segmentation queries in under 30 seconds. So the measurable impact, that is organization implementing advanced SQL, the optimization typically achieve the 60% to 85% of improvements in the query performance, and while reducing the infrastructure costs by the 40 to 60% through the efficient resource utilization here. The query speed and cost reduction and resource usage like this, the graph will be shown here. Finally, the mind map under the advanced SQL in big data, with the SQL evolution, and that is traditional versus the modern distributed we have seen, the sparse SQL architecture, and the query optimization, analytical function, everything has been discussed here. The mind map which is illustrate the concept of advanced SQL within the big data environments, and which is foundation through the practical implementation strategy. Each branch which is represents the critical domains for the massing SQL at the scale. So we just go through the advanced SQL terms in big data technology. What are the things happens in just overview we have seen. So in next class we just go through for the detailed data. So thank you so much.